For most of human history, the night sky was simply a mystery. Ancient civilizations looked up at the stars and imagined gods, myths, and distant realms beyond human reach. The idea that humanity might one day travel among those stars would have seemed impossible, even absurd. Yet today, that ancient mystery has slowly transformed into a scientific question that many researchers take seriously. Could humanity's future lie beyond Earth? At first glance, the idea might sound dramatic. After all, Earth appears perfectly capable of supporting life. Our planet has oceans, forests, breathable air, and a stable climate that has allowed civilization to flourish for thousands of years. But when scientists examine Earth through the lens of deep time, the picture becomes very different. Earth itself is not permanent. Our planet has existed for about 4.5 billion years, yet complex human civilization has existed for only a few thousand. In cosmic terms, humanity has just arrived. And the deeper we study the universe, the more we realize that planets are not eternal safe havens. Asteroids have struck Earth before, triggering mass extinctions. Supervolcanoes can reshape climates. Even the sun itself will eventually expand into a red giant billions of years from now, potentially rendering Earth uninhabitable. These are not science fiction scenarios. They are natural processes written into the long history of our solar system. This realization leads to a powerful contrast. Humanity has developed extraordinary intelligence and technology, yet we still live on a single fragile planet. From a cosmic perspective, that situation may be temporary. Many scientists and futurists argue that if a civilization wants to survive for millions of billions of years, it cannot remain confined to one world. A single planet is vulnerable. One catastrophic event, whether natural or self-inflicted, could end an entire species, but spreading beyond Earth changes that equation. If humanity establishes colonies on multiple worlds, our species becomes far more resilient. A disaster on one planet would not mean the end of civilization. Instead, humanity could continue to grow, adapt, and evolve across many environments. This idea transforms space exploration from a luxury into something much more profound, a long-term strategy for survival. And yet survival is only part of the story. The deeper motivation may lie in something more fundamental to human nature. Throughout history, humans have always pushed into new frontiers, from crossing oceans to exploring continents and reaching the highest mountains. Exploration is not just a practical activity, it is woven into the psychology of our species. Space may simply be the next frontier in that long tradition. But if humanity truly begins to move beyond Earth, the future will not unfold all at once. The vast distances between stars mean that our journey outward will likely begin much closer to home. The first chapter of humanity's expansion into space will almost certainly take place within our own cosmic neighborhood, the solar system itself. If humanity ever becomes a true spacefaring civilization, the journey will almost certainly begin close to home. The solar system itself is vast, containing countless environments that could one day host human activity. While interstellar travel remains a distant dream, several worlds within our own system already stand out as possible destinations for future settlements. Among them, Mars has become the most frequently discussed candidate. Often called Earth's neighboring planet, Mars shares several features with our own world. A day only slightly longer than Earth's, polar ice caps, and evidence that liquid water once flowed across its surface. These similarities have led many scientists to believe that Mars could eventually support human colonies, though surviving there would be anything but simple. The Martian environment is harsh. Its atmosphere is extremely thin, offering little protection from radiation. Surface temperatures can plunge far below freezing, and the soil itself may contain chemicals harmful to human life. Any future settlers would need carefully designed habitats, advanced life support systems, and the ability to produce food in controlled environments. Yet Mars is only one possibility. Much closer to Earth lies the Moon, a world that may become humanity's first permanent foothold beyond our planet. Establishing lunar bases could allow scientists and engineers to develop technologies for long-term space living. The Moon's weaker gravity makes launching spacecraft easier, potentially turning it into a gateway for deeper exploration of the solar system. Another intriguing idea involves living not on planets at all, but in massive orbital habitats. Some physicists have proposed enormous rotating space structures capable of housing thousands or even millions of people. These habitats would simulate gravity through rotation while providing controlled environments where agriculture, industry, and daily life could function normally. Unlike planets, such habitats could be built almost anywhere resources are available. Farther out in the solar system, the icy moons of giant planets present additional possibilities. Worlds like Europa orbiting Jupiter or Titan orbiting Saturn may contain vast oceans beneath their frozen surfaces. Titan even possesses lakes and rivers, though they are made of methane rather than water. While these environments would require extraordinary technological solutions, they remind us that the solar system contains far more diversity than early astronomers ever imagined. However, colonizing any of these places will demand technologies humanity has only begun to develop. Reliable life support systems, efficient space transportation from radiation, and sustainable resource extraction will all be essential. Future settlers may need to produce oxygen from local materials, recycle water continuously, and grow food in artificial ecosystems. These challenges might seem overwhelming, but history shows that technological progress often accelerates once exploration truly begins. Early ocean voyages once seemed impossible as well, yet they eventually connected the entire planet. In a similar way, the solar system could become humanity's next great frontier. But even if our species spreads across multiple planets, moons, and orbital habitats, the solar system still represents only a tiny island in a much larger cosmic ocean. Beyond it lies an almost unimaginable expanse of stars, each potentially surrounded by its own planets. And once humanity learns to survive and thrive across the solar system, the next question will inevitably arise: could we one day travel beyond it and reach the stars themselves? The solar system becomes humanity's first frontier. The stars represent something far more daunting. The distances between them are almost impossible to grasp with ordinary intuition. Light, the fastest thing in the universe, travels at about 300,000 kilometers per second. Even at that incredible speed, reaching the nearest star system beyond our sun, Proxima Centauri, takes more than 4 years. For spacecraft built with today's technology, the journey would take tens of thousands of years. This staggering reality reveals a powerful contrast. Within our solar system, planets and moons may seem distant, but they remain reachable within months or years. Interstellar space, by comparison, is an ocean of extraordinary scale. Yet throughout history, human curiosity has rarely accepted limits easily. Scientists and engineers have proposed several ideas that might eventually allow interstellar exploration, even if the journey requires entirely new ways of thinking about travel. One concept is the generation ship. Instead of sending astronauts on a short mission, a generation ship would function as a self-sustaining world traveling through space. Thousands of people could live inside it, forming a miniature civilization that survives across centuries. The original travelers might never reach the destination, but their descendants could arrive at a distant star system generations later. Another possibility involves cryogenic travel, where astronauts enter a state of suspended animation during the journey. If future technology allows humans to drastically slow biological aging or safely freeze and revive the body, long voyages between stars might become more practical. While this idea remains theoretical, research into cryobiology continues to explore the boundaries of what might be possible. Some scientists have suggested that artificial intelligence and robotic explorers could lead the way. Instead of sending humans immediately, advanced machines might travel to distant systems first, mapping planets and building infrastructure before humans ever arrive. In this scenario, robotic explorers become the pioneers of humanity's interstellar expansion. Even propulsion itself may evolve dramatically. Concepts such as fusion-powered engines, laser-driven light sails, or even theoretical ideas like antimatter propulsion have been explored by physicists. Each concept faces enormous engineering challenges, but they demonstrate that interstellar travel may not violate the laws of physics, only the limits of our current technology. And yet reaching other stars may ultimately change more than just our location in the universe. It may reshape our understanding of identity, culture, and even what it means to be human. A civilization traveling across centuries and light years could gradually diverge from the society that launched it. This realization introduces a deeper question. If humanity spreads beyond Earth, adapts to new environments, and survives across vast distances of time and space, will future spacefaring civilizations still resemble the humans who first looked up at the night sky? The answer may lie not only in where humanity goes, but in how the journey itself transforms us. If humanity eventually spreads across the solar system and perhaps even reaches other stars, the journey will not only change where we live, it may also transform what we are. For most of our history, human evolution has taken place under the stable conditions of Earth, its gravity, atmosphere, and climate shaping every aspect of our biology. But beyond our planet, those familiar conditions disappear. Space is not simply another environment. It is fundamentally different from anything life on Earth has experienced before. Consider gravity. Human bodies evolved under the constant pull of Earth's gravity. In low-gravity environments such as the Moon or Mars, muscles weaken and bones gradually lose density. Astronauts already experience these effects after only months in orbit. Over generations, however, humans living in reduced gravity might physically adapt. Future Martian settlers, for example, could develop lighter skeletons or different body proportions suited to their environment. Radiation presents another challenge. Earth's magnetic field shields us from much of the harmful radiation constantly streaming through space. Outside that protective barrier, exposure becomes far more intense. Long-term space populations may rely on advanced shielding technologies, underground habitats, or even genetic adaptations that improve resistance to radiation damage. Technology itself may also reshape humanity. As artificial intelligence, biotechnology, and cybernetic systems advance, future humans might enhance their own capabilities in ways that blur the boundary between biology and machine. Neural interfaces could allow direct interaction with computers. Artificial organs might extend human lifespans. Genetic engineering could alter how our bodies respond to extreme environments. These possibilities introduce a striking contrast between the humans of today and the humans of the distant future. The first explorers leaving Earth may still resemble us closely, but centuries of adaptation to new worlds could gradually create distinct spacefaring cultures and perhaps even distinct branches of humanity. Imagine a civilization that has lived on Mars for hundreds of generations. Its people might think differently about time, resources, and survival. Life on a harsh planet would require cooperation, careful planning, and constant awareness of environmental limits. In orbital habitats, societies might develop entirely new relationships with space, architecture, and community life inside rotating artificial worlds. Over long periods, these separate environments could produce diverse human civilizations scattered across the solar system. Each world would shape its inhabitants in subtle ways, physically, culturally, and technologically. And yet, despite these differences, all of them would share a common origin. Every future colony, every space habitat, and every distant settlement would trace its roots back to a single fragile planet orbiting an ordinary star. As humanity transforms and spreads outward, the scale of our presence in the universe may grow far beyond anything our ancestors could imagine. Which leads to one final and profound question. If humanity survives long enough to expand across planets and stars, what role might our species ultimately play in the larger story of the cosmos? If humanity eventually spreads across planets, moons, and perhaps even distant star systems, the story of our species will no longer be confined to a single world. For billions of years, the universe evolved without conscious observers capable of understanding it. Stars formed, galaxies collided, and planets emerged in silent cosmic processes unfolding across unimaginable spans of time. Then, on one small planet orbiting an ordinary star, something remarkable happened. Matter organized itself into life. Life evolved into intelligence, and intelligence developed the ability to question the universe itself. From this perspective, humanity represents more than just another species struggling to survive. We are part of a much deeper process. Through science, exploration, and curiosity, the universe has produced beings capable of observing its own structure and asking why it exists at all. If humanity remains confined to Earth, that awareness might remain limited to a single fragile location. But if we expand beyond our planet, carrying knowledge, culture, and consciousness to new worlds, the scale of that awareness could grow dramatically. Each colony, each space habitat, and each distant settlement would become another place where the universe observes itself through thinking minds. This idea transforms space exploration into something larger than technological progress or economic expansion. It suggests that intelligent life may play a meaningful role in the cosmic story. Wherever conscious beings emerge, the universe gains the ability to reflect on its own existence. Yet this possibility also carries responsibility. A civilization capable of leaving its home planet must also learn how to survive its own technological power. Throughout history, humanity has created tools that reshape the world, sometimes faster than we understand their consequences. As our capabilities grow, the challenge will be learning how to guide that power wisely. The future of humanity in space will not depend only on rockets or engineering breakthroughs. It will depend on whether we can solve the problems that exist here on Earth: conflict, instability, and the struggle to cooperate on a global scale. A civilization divided against itself may never reach the stars, no matter how advanced its technology becomes. But if humanity succeeds in overcoming those challenges, the long-term future could be extraordinary. Millions of years from now, distant descendants of our species, or perhaps new forms of intelligence we create, might inhabit worlds scattered across the galaxy. Entire civilizations could arise under alien skies, shaped by environments very different from the one that gave birth to humanity. And yet, no matter how far that future civilization spreads, it will always carry a connection to its origin, a small blue planet, an ordinary star, a species that once looked up at the night sky and wondered what lay beyond. In that moment of curiosity, the first step of humanity's cosmic journey had already begun.